Hello lovely year 12s. So last of our food molecules. So we've looked at our proteins, we've looked at carbs. Now we've got something to cook with and to make us nice and insulated. So fats and oils. So fats, oils are the main ones we're going to be looking at, but this whole group of the food molecules is really lipids. That include some of our vitamins that we're not doing anymore. So remember, ignore the word vitamin. And it also, some of our waxes and soaps counts as foods, fats and oils and lipids. So what we're really looking at is a fat, which is our lipid, which is a solid at room temperature. So these are like butter, the fat on your body, animal fat, coconut oil would be, I suppose, a fat. Then oils are liquid at room temperature, so olive oil, cooking oils, peanut oil, any of those kind of things you can get and you can pour at room temperature. A lipid. So when I looked in the book, the description of lipid was a fat or an oil, and I was like, well, that's kind of a circular description if you don't know what one of those is. Anyway, so it's an organic molecule that dissolves in alcohol but not in water. So if you think about, you're pouring some oil on the water, it sits on the top and floats. It doesn't mix with it and dissolve. Then we've got lots of terms. Vocab is going to be important for this section. I mean, it's important all the time, but it's important for this section because it's kind of a lot of what the questions are going to be based around. That we know, kind of fudging, figuring it out, kind of working around in the same kind of way. So what we're looking at is, with our fats and oils, is organic molecules with hydrogen, carbon and oxygen only, and we've got less oxygens than our carbs. They're not going to ask you this kind of question. So the questions they are going to ask are going to be around triglycerides. So triglycerides are a glycerol and 3 fatty acids. So what does this mean? Well, it's good. Again, we've got our data book. So our data book gives us glycerol. So this is our glycerol, and this is like the backbone of our fatty acids. So our triglycerides, 3, and then we've got our fatty acids here. So we've got 3 of them. We'll attach here and here, and we've got a condensation reaction happening again. So we end up with 3 waters coming out because we've got 3 OHs that we can get our fatty acids attaching to. So they give you the fatty acids here. That's really okay. So they give them fatty acids, but they don't put the name here, acid. These are all fatty acids. So if you are writing which one is it, you would write aloic acid or mysteric acid or lauric acid. So you're not going to just write lauric. Let me zoom in a bit better. You're going to write lauric acid, mysteric acid, and so on and so on. They give you the formula, and then they give you some semi-structural formula. This is really important. This is what you can just add when you do your showing me or the examiner a triglyceride. But this is going to then help you with some of the descriptive properties of your triglyceride. So we can see from this, with the semi-structural that they've very nicely given you, that we have some double bonds. Where's my highlighter? So there's no double bonds till we get here. There's one there. So we have this double bond here with our linoleic acid is in that bracket, and there's 2 of them, so that means I have 2. Then this one is 3 for linolenic. Yep, no one's going to make you say it. I'm sure I'm butchering it. There's none there. And 1, 2, 3, 4. So that's how many double bonds. This is going to come round when we look at saturated versus unsaturated fatty acids. So what we do is we get our glycerol in our booklets, and we've got this end here. So again, with the highlighting, and what happens is they may ask you to draw this out and show what happens. So what we have is, I'm drawing a line so it's kind of separated, but no, I don't think it's completely wrong to do that. Maybe don't. So remember, it's condensation, so condensation means we're losing our water. So we've got, this is our glycerol here. Then we've got our fatty acids, which come from the book and have our general formula that we can see as this with an R. And then we've got 3 different of these fatty acids that can join in here. So they can be the same, they can be different. They're going to be the ones listed in the book. I can't imagine they're going to give you a different one. That would seem a bit weird, as they have given you a list. So they might ask you to see this. And it's the opposite round. So I'm showing this group, this bit here, to that side, because it's much easier for me to do the bonding that way. So we're going to be losing the water. Kind of isn't going to matter. So there's our water being lost off here. Water being lost off here. And then a water being lost off here. So we've got this structure. I've got examples I've seen. It is perfectly acceptable to have these kind of not to scale bonds in here, just because sometimes you have quite a lot of information you need to squash in, and really it's just about showing you know what's going on, rather than you know, being a perfectly accurate representation, because this is not a perfectly accurate representation anyway. So these could be any of these ones we have here to make our triglycerides. So 3 of them joining with our glycerol on this side, and then our fatty acid joining on this side. So if we had this fatty acid here was palmolate, that one, we could just here write COR, and then that could be replaced with C15H29. And then if this one is Linoleic, that one. Linoleic. I can keep saying it. I'm not quite sure how I'm saying it. Oh. And then that one could be this one. Arachnidinoic. I'm assuming that comes from spiders or something, but that's just me kind of making it up. I'm assuming that seems kind of the Latin for it. So if we are given a question where it's identify what they are, so you're given a you're given the triglyceride and you have to identify the fatty acids. You're looking at this bit here because this is your kind of glycerol head, I'm going to call it. It's kind of the head and that's kind of the tail. This is my biology thinking. And remember, compared to our data book, they're flipped round. So this I'm showing at that end and it's kind of twisted around that way. Just to make it easier for me to draw. You could do it the other way. Same. So we've got our triglycerides and that's how they're made. And we're going to, in another video, I'll talk about going the other way. So going from a triglyceride to making our fuels. So properties. So we have different structures give us different melting points. So we have different lipids have got different structures because we've got different groups on the end. So we've got these different groups that are going to give it different properties and it's going to be on a variety of different things. So there's different things that can give us the different properties. So, oh, and this is a tricky one because it's explicitly in the dot points, but I didn't find it very explicit in the textbook. So if we have these saturated fats, so if it's saturated, it's a fat because it tends to have a higher melting point. So it's solid at room temperature. I mean, your room temperature may vary, but it's generally saturated means it's just got these carbon-carbon single bonds. So carbon-carbon single bonds only, just like all organic chemistry. This means it's a straight chain and it can all pack closer. So if we're looking at them as a diagram, this is my biology thing. It's going to look like that because all of my carbons are going to kind of line up with each other. Like that. Pretty lined up. So that means if I have lots of them all kind of lined up like this, they're going to be able to come quite close to each other. So my saturated triglycerides are going to be able to have intermolecular bonding between them. And quite a lot. If you think about these going on and on and on, it's really quite a lot. And the longer they get, the more bonds there are. So they're going to be hard to separate. Well, hard to separate means we need to put some energy in. So it means that we have quite a high melting point because we've got all of this bonding. So trying to separate them all apart, it's going to be quite tricky. It's not that tricky in the big scheme of things, but compared to others, it's going to be quite tricky. So that's if they're saturated. So, you know, your butter and your lard and animal fats like that, like bacon grease, this is kind of what their structure is going to be like, and it's hard to pull them apart. But unsaturated, so you're just seeing these words in food tech and like, these are generally our oils. So they have these double bonds, so they're unsaturated. This makes the structure of them bent. So if we think about just that carbon, so if we have double bonds, it makes them kink. So it makes them kink in shape And that's not going to be the same for all of them. So if we have this kinking here, and then we've got some more different kinking here, and then the one here is we've got these double bonds at these different points here and here. It means they're not going to be as close to each other, so we might get some intermolecular bonding here, but this is too far apart to do that intermolecular bonding, and this is definitely too far apart. There might be some intermolecular bonding here, there might be some intermolecular bonding here, but generally it's going to be too far apart to do that intermolecular bonding. The longer they get, again, there's more likely to be these intermolecular bonds that make it closer together. So it's going to make it more viscous, more likely to have a higher melting point. So we could think about what's one that would maybe comparing olive oil and vegetable oil. I don't know off the top of my head which one, but they're going to have different numbers of these intermolecular bonds, and it means if we're heating them, they're going to have different like boiling points or different melting points. So if we froze them and watch them defrost, their melting point is going to be very different. So that's the takeaway from this unit. So lots of terms, we'll come back to them. Fat and oil, so that's our difference between our like butter and olive oil. Lipid is an organic molecule that we're talking about in this thing, but also includes other ones that you don't need to know. Triglyceride is our large non-polar molecule that has a glycerol and our 3 fatty acids. What's the fatty acid? It's a carboxylic chain with a long carboxylic acid with a long hydrogen carbon chain, as we can see in here. We've got that group here and then this long chain here. Monounsaturated, there's just one carbon double bond. Mono is 1. Saturated, we've only got those single bonds. Polyunsaturated, more than one carbon double bond. This is kind of what we would see like on your oils and things. And unsaturated, it's got some carbon double bonds. These two are kind of interchangeable. This just means it's got lots of them compared to that one. So these two kind of pair up, and then with our unsaturated you can kind of divide it into mono and poly. So that's kind of my takeaway view of what we need to know. Throw me any questions, I'll give you some questions, and hopefully that's it for the food molecules. Then we're going on to our metabolism, and then we're going to look at of these food molecules, so you've got to know what they are, and then we're going to look at measuring how much energy we have in our food.